Now let us look at images formed by concave mirrors. The first case is that the object is placed between the pole and the focus. So this here is the pole of the mirror and this point is the focus, principal focus F of the mirror. So let us draw an object between pole and focus of the mirror. In the last video, we have seen the three rules of drawing ray diagrams. You can either choose ray parallel to principal axis, which after reflection passes through focus. The second rule is that if a ray passes through focus, it will go parallel to the principal axis. And the third rule is that if the ray passes through center of curvature, it will retrace its path. Let us choose two rays such that first incident ray is parallel to the principal axis. So this ray, incident ray, is parallel to the principal axis. Now after reflection, it has to pass through the focus. So this is the focus and ray has to pass through the focus. So incident ray parallel to principal axis after reflection passes through the focus. Now what we do is we find the point of intersection of the two reflected rays and that will be image of the top part of the object. The bottom part of the object will remain on the principal axis. So we can drop a perpendicular from the image that we obtain by intersection point of the two reflected rays and then complete the image. So this is the first ray, incident ray parallel to principal axis after reflection passing through the principal focus. Now second ray, let us choose passing through focus. So the incident ray passes through focus and then goes on to the mirror. Let us extend that ray. So this is the incident ray passing through focus and the top part of the object. How will it get reflected? After reflection, it will go parallel to the principal axis. After reflection, it will go parallel to the principal axis. Now we can see that this is the first reflected ray and this is the second reflected ray. We can clearly see they are not going to meet in front of the mirror. So what we do is we extend the rays back. So rays, we extend them back. First we extended the first reflected ray and now let us extend the second reflected ray. As a result, we can see that we have obtained a point of intersection. That will be the image of the object, point of intersection. Let us mark that point and then drop a perpendicular to the principal axis. So this will be the image. So let us name the mirror, mark out the important points. Mirror is MN. This is pole of the mirror. This point is focus. This is center of curvature. The object is named AB and the image will be A dash B dash. So let us recap how we arrived at this image. So the incident ray parallel to principal axis after reflection passes through focus. We have extended that ray behind the mirror. Second ray we have chosen is ray passing through focus. After reflection, it goes parallel to the principal axis. We have also extended it behind the mirror. We get point of intersection behind the mirror. We name it A dash because it is image of point A. Then we drop a perpendicular from A dash onto the principal axis and name it B dash, the image of point B. We join the 2 points and get the image. Now as we can see, object is smaller than the image. So we can say that image is magnified or enlarged. Now where is the image? Is it in front of the mirror? No, image is behind the mirror. So let us write the properties of this scenario. The case was object is between pole and principal focus. Where has the image formed? Image is behind the mirror, behind the mirror. Now what about the nature? As we can see, image is behind the mirror. The area in front of the mirror, the image formed is real. If the image forms behind the mirror, it is virtual because it cannot be obtained on the screen. And we can see that it is upright as the object. So we call such an image erect image. So image is erect and virtual. And what about its size? Size is, as we can clearly see, larger than the object. So we call the image magnified. We call the image magnified. So if the object is placed between pole and focus, this is the object here, AB, then the image formed is behind the mirror. The nature of the image is erect and virtual, and size of the image is magnified. In the second case, the object is placed at the focus. So let us draw an object at the focus. Let us choose the same two rays. Here, instead of using rule 2, we will need to use rule 3 because we cannot draw a ray passing through focus and the upper part of the object, because it will go like this. So we will use first rule and third rule. So first rule is incident ray is parallel to the principal axis. After reflection, it goes through the principal focus. So ray will pass through the focus. Incident ray parallel to the principal axis. After reflection will pass through the focus. Now for the second ray, we will choose a ray which is passing through center of curvature and the top part of the object. So passing through center of curvature and the top part of the object. And after reflection, it will retrace its path. After reflection, it will retrace its path. Let us mark out the points. Center of curvature C, principal focus F, pole of the mirror P, mirror MN, and object AB. Now we can see that these two lines are parallel to each other. As a result, they will not meet. So we say that they meet at infinity, that is at an extremely large distance in front of the mirror. So let us write the details of this scenario. So they meet at infinity because these two lines are parallel to each other. So first one is object. How is the object? Object is at the focus. Object is placed at the focus. Where is the image? Image is formed at infinity. Image is formed at infinity. Now, because the image is forming in front of the mirror, we call that image real image, and real images are always inverted, that is upside down. So, nature of the image will be inverted and real. And what about its size? Size is very large because they are not actually going to meet. So, size we say is very large. Now, the third case, the object is placed between focus F and center of curvature C. So, let us draw the object. Now, the first ray will be parallel to the principal axis. So, ray is parallel to the principal axis. What will happen after reflection? After reflection, it will pass through principal focus. So, ray gets reflected and passes through principal focus. Passes through principal focus. Now, for the second ray, let us consider rule 2. Ray passing through principal focus, after reflection, it will go parallel to the principal axis. It will go parallel to the principal axis. And see, here we have the point of intersection. Let us drop a perpendicular on the principal axis from this point of intersection. Let us name the mirror first Mn, the pole of the mirror P, the focus F, center of curvature C, and now on to the object and the image. Object is AB, image is A dash, B dash. Now what can you observe regarding this image? We can see that image is formed in front of the mirror. Images formed in front of the mirror are real, and we can clearly see that it is upright down. So, real image and inverted. Always remember, real images are inverted and virtual images are erect. So, we have real inverted image. Where has the image formed? We have object between focus F and center of curvature C, and image is formed beyond C. So that will be the position of the image. Nature will be inverted and real. Position will be beyond C. Now let us look at its size. We can clearly see that image is larger than the object. Hence, we will say that image is magnified. Let us note it down. First, let us talk about object. Where is the object? Object is between focus and center of curvature. Between focus and center of curvature. Now, where is the image? Image is beyond the center of curvature. Beyond the center of curvature. What about the nature? Nature of the image is inverted and real. Inverted and real. And final point about the image, what is the size of the image? We can clearly see image is larger than the object, hence we call it magnified. Hence we call it magnified. Now on to the fourth case. The object is placed at the center of curvature. It is observed that image is also formed at the center of curvature. So if we place an object like this, image will be formed again at the center of curvature. It is also observed that size of the object is same as size of the image. So there is no change in its size. But while drawing ray diagrams, what happens is, due to the curvature of the spherical mirror, we do not get exact results. So to fulfill the experimental observations, what we do in this and only this scenario is that we will first draw the object and the image, and later the point of intersection on the principal axis we will mark it as focus, just for this scenario, because due to the curvature of the spherical mirror we do not get accurate ray diagram. So let us first draw the object. So object AB, let us duplicate it and draw the image. This is based on experimental observations. First incident ray is always parallel to the principal axis. After reflection, it passes through the focus. We have not marked focus here, but it has to pass through the top point of the image. Extend it further. So incident ray, reflected ray. Now let us look at the reflected ray in the second scenario, which will go parallel to the principal axis, and incident ray will be passing through focus. So here we get the point F, focus, C center of curvature, P pole, MN the mirror, and object AB and image A dash B dash. We have to do this due to the curvature of the lens. If you draw this ray diagram in the notebook, you will see that there is a slight shift in the focus. Focus is not exactly at the center of the pole and center of curvature, not exactly in the middle of it. That is because of the curvature of the lens. But experiments have concluded that when object is placed at center of curvature, image of the same size is obtained at the same point. So let us write details regarding this. Object is placed at the center of curvature. Image is also at the center of curvature. What is the nature of the image? We can clearly see that image is formed in front of the mirror. It is of same size and it is inverted. Images in front of the mirror are called real images and it is upside down, so inverted. So nature is inverted and real. and size is same as the object. Same as the object. Now the fifth case, object is placed beyond center of curvature. So this is center of curvature. We place object beyond center of curvature, that is behind center of curvature. So let us draw an object behind center of curvature. So here we have the object behind center of curvature. First ray, as always, ray parallel to the principal axis. After reflection, where it will pass through? It will pass through the principal focus. So it will pass through principal focus. Now the second ray will be passing through focus. So second ray passing through focus. After reflection, it will go parallel to the principal axis. So incident ray passing through focus F, reflected ray going parallel to the principal axis. Do we have a point of intersection? Yes. This is the point of intersection. Let us drop a perpendicular onto the principal axis. That will give us the image. Again, you can see image is in front of the mirror and it is upright down. So real and inverted. Can you compare the size of the image to the size of the object? You can clearly see image is smaller than the object. Hence we call such image diminished. Smaller images are called diminished. And what are larger images called? They are called magnified. So let us mark all the points. Mn is the mirror, P is the pole, F is the focus, C is the center of curvature, AB the object, A dash, B dash the image. Let us write the details. So object beyond the center of curvature. Beyond the center of curvature. Image between focus and center of curvature. So image is between focus and center of curvature, but object is beyond center of curvature. If you compare it with the third case, in third case, object was between focus and center of curvature and image formed was beyond center of curvature. So here the two situations have swapped their places. Position of object has become position of image and position of image has become position of object. What about its nature? So nature is inverted and real, and size is diminished. Smaller images are called diminished. So when object is placed beyond center of curvature, image is formed between the focus and the center of curvature. Here the image is formed. Image is real and inverted and of smaller size. Hence it is diminished. Now the last case where object is at a very large distance. So basically object is so far away that all the rays coming from it are parallel to the principal axis. So because object is at a very large distance, all we can see is the parallel rays coming towards the mirror. An example would be if we try to form an image of the sun using concave mirror. So sun is at such a large distance that practically we can say that rays coming from the sun are parallel to the principal axis of the mirror. So let us see what happens in this scenario. So let's say we have parallel rays, incident. Let us draw more than two rays, replicate it. So as all the rays are parallel to the principal axis, through which point will they pass? Of course, they will pass through the principal focus. So first ray after reflection will pass through principal focus. The second ray after reflection will pass through principal focus. The third ray again will pass through principal focus, and also the fourth ray will pass through principal focus. We can clearly see that all the rays pass through this particular point, which is principal focus F. Let us mark all the important points. All the rays meet at the focus. That is why we can say that image is formed at the focus. If you recall the second situation, when object was placed at focus, image was formed at infinity. So if object is at infinity, that is a very large distance, image is formed at focus. Let us write the details. Object is at a very large, that is infinite distance. Image is at the focus. Nature, again because image has formed in front of the mirror, image will be real, and real images are always inverted. So inverted and real, and finally size. We will see that object, whatever size it may be, image is a point, a single point. So we call it point image. Size is point image. So these are images formed by concave mirrors in 6 different conditions. In the next video, we will cover convex mirrors.